selected variant 21 and it's of October, November 2024. You know the times, 1 hour 45 minutes. It's paper 2 theory. You have to answer all the questions. You can use calculator in this paper. The total mark for this paper is 80. Periodic table is printed in the question paper. So let's start with question number 1. Number 1A. Figure 1.1 shows the electronic configuration of 5 atoms D, E, F, G, and H. So here's figure 1.1 showing electronic configurations of 5 atoms. Answer the questions about these electronic configurations. Each electronic configuration may be used once, more than once, or not at all. State which electronic configuration D, E, F, G, or H represents. Number 1, an atom of an element in group 6 of the periodic table. So here's group 6. If an element is present in group 6, it means it must be having 6 valence electrons, right? 6 valence electrons for group 6 elements, because the group number represents 6 as the valence electron. So count the valence electron for all of these electronic configuration. For D, it's 2. For E, it's 4. For F, it is 8. For G, it's 6. So G must be the final answer for this one. For convenience, I'm checking the last one also, that is H. And there is only 1 electron in its valence shell. So it's incorrect. So G will be the final answer. Number 2, an atom that forms an ion that gives a lilac color in a flame test. You see potassium, it's in group 1. It forms a lilac color in flame test and the electronic configuration is 19. And it must be having 1 valence electron. But you have to count all the electrons. Looking at these choices, I have H. If you count the electrons in H, it must be 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 electrons in H. So H must be the potassium that gives a lilac color in a flame test. So you'll write H here. Number 3, an atom of a monatomic gas. So group 8 elements, they all exist as monatomic gas. So the proton numbers, you have 2, 10, 18, 36. So any one of these having 2, 10, 18, or even 36. We don't see any atom with only 1 shell, because in the first shell you will have 2 electrons. So we can't have 2. What about 10? I can see F having 10 electrons, which means F must be the element from group 8. So it must be the having an atom of a monatomic gas. F is the final answer for this one. Number 4, an atom of an element that is used in the treatment of the domestic water supply to remove taste and odor. To remove taste and odor, carbon is used. Carbon is used. So carbon, where is carbon? Here is carbon. The proton number of carbon is 6. It means you have to look for the element that must be having 6 electrons. Total electron must be 6. If you look at the electronic configuration, E seems to be the right answer because it's 1, 2, 3, 4, 5, 6. There are 6 electrons in this. So E must be the final answer for part 4. Number 5, an atom that forms a stable ion by losing 2 electrons. Now, if an atom loses 2 electrons, forms stable ion, it means it must be having 2 valence electrons. So D seems to be the correct answer because you see there are 2 valence electrons, 1, 2. So it will form stable ion by losing this 2 electrons. So D must be the final answer for number 5. B, deduce the number of protons and neutrons in the chromium atom shown. Small number is the proton number. So the number of proton must be 24. What about number of neutrons? You have to subtract the number of protons or proton number from the nucleon number. So 53 minus 24. The answer is 29. So 29 must be number of neutrons. Moving to next question, which is question number 2, part A. Iron is extracted in a blast furnace by the reduction of iron 3 oxide with carbon monoxide. Here's the reaction equation. Fe2O3 plus 3CO gives 2Fe plus 3CO2. 1. This reaction is a redox reaction. State the meaning of the term redox reaction. Redox reactions are those reactions in which oxidation and reduction taking place at the same time or occurs simultaneously. So I will write oxidation and reduction taking place at the same time or occur simultaneously. Number 2, explain how carbon monoxide acts as a reducing agent in this reaction. Now, carbon monoxide is removing oxygen from iron 3 oxide, which means it's gaining oxygen from iron 3 oxide. So you can either write it removes oxygen or gains oxygen. Removes or gains oxygen from iron 3 oxide. Part B. Calcium carbonate is added to the blast furnace. The calcium carbonate undergoes thermal decomposition. Here's the reaction equation. CaCO3 gives CaO plus CO2. The thermal decomposition of calcium carbonate is endothermic. Complete the reaction pathway diagram in figure 2.1 to show the reactant and products. The labeled arrow for the activation energy, EA, a labeled arrow for the enthalpy change, delta H. So for the endothermic reaction, product must be at the high energy state than the reactant. Product at high energy state than reactants. So reactant must be at the low energy state. So I'm going to show the reactant here. This is reactant and here's energy hum, and then we have product. So write down the symbols for the reactant, which is CaCO3. So I'm writing CaCO3. Products, we are having calcium oxide, which is CaO, plus carbon dioxide, CO2. Now they are saying labeled arrow for the activation energy. This must be the activation energy starting from the reactant side and reaching at the top of the hump. We are representing it with EA. And delta H, that is enthalpy change, must be between reactant and product. It's also going up because it's absorbing energy. So this will be the final label diagram for this. Number C, describe how slag is formed in the blast furnace. Include a symbol equation in your answer. Now you have to include symbol equation in your answer. So you have to describe first. So what's happening? It's actually calcium oxide that reacts with silicon 4 oxide. Calcium oxide reacts with silicon 4 oxide. Silicon 4 oxide is also known as sand. You can even write the formula, which is SiO2. Now reaction equation, which is CaO plus SiO2. The product obtained is calcium silicate, which is CaSiO3. Moving to next part, which is part D. Iron is a transition element. Transition elements have colored compounds. State two other physical properties that are typical of transition elements and not of group 1 metals. Here's group 1 metal, and here we are having transition elements. Transition elements are between group 3 and group 2 and group 3. So these all are transition elements. You have to write any two physical properties that are typical of transition elements but not of group 1 metals. You know, group 1 metals, they are soft, they have low density, low melting point, they are not used as catalysts, they have fixed valency, they have +1 as their valency or oxidation number. So these are the properties which are not shown by transition elements. Transition elements are hard. So you can write any two from, you can write hard, or you can write high melting point. Transition elements have high melting points. High density. They have variable oxidation number. Or they can be used as a catalyst. Used as a catalyst. Group 1 metals, they are not used as a catalyst. So you can write any two from these. E, the equation shows the decomposition of iron pentacarbonyl FeCO whole 5 in a closed container. There is the reaction FeCO whole 5 L, reversible sign, Fes plus 5 COG. Number 1, predict and explain what happens to the position of equilibrium when the pressure is decreased. The temperature remains the same. Remember, this is a reversible reaction. It reaches to dynamic equilibrium state in a closed container, because they are saying in a closed container. So it has definitely reached to dynamic equilibrium state. So whenever reversible reaction in a dynamic equilibrium state, so the effect of pressure is that if you increase the pressure, the dynamic of the equilibrium, it will shift to the side with less number of moles or less number of molecules or volume of gases. But if decrease the pressure, the reverse will be true. So the prediction. So first of all, I'm going to write the number of moles, molecules, or volume of gases. So you will have better idea in which direction it will be. Number of moles, molecules, or volume of gases. So on the reactant side, it's 0. You can't see any gas here. What about the product side? It's 5. We have only one gas, that is carbon monoxide here. So 5 moles of carbon monoxide. So if you decrease the pressure, it will shift to the side with higher number of moles. So equilibrium definitely shift to right hand side or product side. Now, what about the explanation? Refer number of moles. Refer number of moles molecules or volume of gases on either side of the reaction. Number two, this reaction can be used to produce a pure iron. Describe and explain why, referring to the equation, how a sample of pure iron that is free from FeCO5L is produced from the equilibrium mixture. We need only iron from the reactant, and we have only one reactant. The reactant will be converting into products, and the products here are iron and carbon monoxide. Carbon monoxide is a gas, so you can have open system so that you will allow, or you are letting CO to escape. So you write open system. Or you can write let CO escapes, which means shifts equilibrium to the right hand side. You have to shift the equilibrium to the right hand side. And how you're going to do this? You will increase the amount of the reactant. F. Iron reacts with hot concentrated sulfuric acid. The products are iron 3 sulfate, sulfur dioxide, and a liquid that turns anhydrous copper 2 sulfate blue. Construct the symbol equation for this reaction. First of all, I'm writing the reactants. We have iron here. Symbol of iron is Fe. Hot concentrated sulfuric acid, it must be H2SO4. They didn't ask for the state symbols, so no need to write the state symbols here. What about the products? The products are iron 3 sulfate. Iron 3 sulfate means iron is carrying +3 valency or oxidation number. Sulfate, it is -2. Ignore the charges. Now swap these numbers. So you'll get Fe2. Fe2, I will write it down here first. Fe2 SO4 whole thrice. So Fe2 SO4 whole thrice plus, they are saying sulfur dioxide is also produced, so you write sulfur dioxide SO2 plus, and the liquid that turns anhydrous copper 2 sulfate blue, it must be water, phase water. Now let's balance this equation. Fe2SO4 whole thrice, so I will write 2 before Fe. Iron is balanced. What about sulfate? In order to balance the sulfate, you can't write 3 before H2SO4 because you are also getting sulfur dioxide. So what if I will write, first let's balance sulfur. We have 1 atom of sulfur on the reactant side. On the product side, we have 4 atoms of sulfur. So what if I will write 4 before H2SO4? Okay, let's write 4 before H2SO4. Sulfur, it's 4 here, it's balanced. Yes, it's balanced. What about hydrogen and oxygen? Hydrogen, 4 2s are 8. So I will write 4 before H2O. Hydrogen is balanced. Yes, it's also balanced. Oxygen, 4 4 the 16. So on the product side, there must be 16 atoms of oxygen. 4 3 the 12, 12 plus 2, 14, 14 plus 4, just 18. So 8, 16, product side, This is reactant. This is product side. This is incorrect. So it means 4 will. Let's increase the number. What if I will write 5 H2SO4? So 5 fours are 20 for oxygen on the reactant side. So on the product side, 3 fours are 12. 12 plus 2, 14. 14 plus 5, 19. Again, it's not balanced. Okay, let's try with the number 6 here. Now the sulfur, it becomes 6 this time. So on the product side, we need to write 3 before SO2. Sulfur is balanced. Yes, sulfur is balanced. What about hydrogen? Hydrogen 6 to the 6, 12. So I will write 6 before H2O. Hydrogen is balanced. Yes, it's balanced. What about oxygen? 6 fours are 24 on the reactant side. What about the product side? 3 fours are 12. 12 plus 3 to the 6. 12 plus 6, 18. 18 plus 6, 24. It's balanced now. All are balanced. This will be the final balance equation for this reaction equation. Question number 3. Figure 3.1 shows the apparatus used for the electrolysis of concentrated aqueous sodium chloride using graphite electrodes. So here's a graphite electrode. A, label the cathode on figure 3.1. Cathode is the negative electrode, so this must be cathode. B, explain why concentrated aqueous sodium chloride conducts electricity. It must be due to the presence of mobile ions. In aqueous solution, you have mobile ions. That's why it conducts electricity. Part C1. Name the product formed at the cathode. So in case of concentrated aqueous sodium chloride, you will get hydrogen gas, because hydrogen is less reactive than sodium, or reverse argument, hydrogen is below sodium, or hydrogen have high ease of discharge, low difficulty of discharge. You can write any of these. You can consider any of these reasons for the product obtained at cathode. Number 2, chlorine is formed at the anode. When you are having concentrated aqueous sodium chloride, you will get chlorine at the anode. Construct the ionic half equation for the reaction at the anode. So it must be loss of electron at anode. So you have Cl negative ion losing 2 electrons. You know that chlorine exists in the Cl2 state, so we'll write 2 Cl2. Well, let's balance the equation. So it must be 2 here and 2 electrons. D, graphite is suitable as an electrode because it conducts electricity. State 1, other property of graphite that makes it suitable for use as an electrode. It's inert or unreactive. You can either write inert or unreactive. Part E, state the product formed at the cathode when molten sodium chloride is electrolyzed. Now, you are only having sodium chloride. You are not having any kind of H positive ion or OH negative ion in the solution. So you are only having sodium chloride, molten sodium chloride. So in case of molten sodium chloride, you will get sodium at cathode. Moving to next question, which is question number 4. This question is about alkanes and alkenes. A, but1ene belongs to the alkene homologous series. Members of the same homologous series differ from one member to the next by a CH2 group and have similar chemical properties. State two other characteristics of a homologous series. You have to state any two other characteristics. So you can write any two from these. Any two from these. So homologous series, they have same functional group. Same functional group or same journal formula. They all will follow same journal formula. And there's always a trend in physical properties. So you can write trend in physical properties. There isn't any variation. So you can write any two from these. B, figure 4.1 shows the displayed formula of but1ene. Here it's but1ene. You have to start counting from right hand side. This must be carbon 1, 2, 3, 4. That's why it's but1ene. Ene means it's from alkene. That's why name ending on ene. Number 1, explain how figure 4.1 shows that but1ene is an unsaturated compound. So you can write contain carbon-carbon double bond. You see, carbon-carbon double bond. You can write contain carbon-carbon double bond. What else you can write? Not all the carbon-carbon bonds are single. You see, we have only two carbon-carbon single bonds. The third one is carbon-carbon double bond. So you can write not all the carbon-carbon bonds are single. Number 2, give the structural formula of but1ene. Now they are asking you to write down the structural formula. So I'm starting from left hand side, that's fourth carbon, we have CH3. Then we are having CH2. Then we have CH. Now there's a double bond. You have to show the double bond, the structural formula. So I will show the double bond, CH2. So this will be the structural formula. Number 3, draw the displayed formula of an isomer of but1ene. So for the isomer of but1ene, you have two options. Either draw displayed formula of first isomer due to the different position of carbon-carbon double bond. You can also have but2ene in this case of but2ene. Now the next isomer must be methyl, 2-methyl but1ene, 2-methyl but1ene. So you can draw the displayed formula of any of these. If you want to draw the displayed formula of but2ene, you must have carbon-carbon double bond between second and third carbon. So now I am saturating this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, showing the hydrogen atom. This is the displayed formula of but2ene. What about 2-methyl but1ene? Sorry, you can't have 2-methyl but1ene. You have 2-methyl propene. 2-methyl propene. It's not butene, it's propene. I made a mistake. It must be propene because there must be 4 carbon atoms in all. So you have 1, 2, 3. And there is double bond between any two carbon. So I'm showing between these two. And there's a methyl group on the second carbon. So this is the methyl group. One, two, three, four. Second carbon, it's already saturated. No need to place any hydrogen. Third carbon, 1, 2, 3, 4. Placing hydrogen atoms. It's saturated now. This is 2-methyl propene. You can draw any of these in your answer. C. Undecaying C11H24 is present in the kerosene paraffin fraction from the distillation of petroleum. Number 1, give one use of kerosene or paraffin fraction. It's used as jet fuel. So you write jet fuel. Number 2, when undecaying is cracked, shorter hydrocarbon molecules are formed. Construct the symbol equation for a reaction in which undecaying is cracked and the only products are butane, propene, and ethene. So the formula of undecaying is C11H24. You know the formula. Of butane, it's C4H10, propene, C3H6. What about ethene? C2H4. So let's count the carbon atoms first. 4 plus 3, 7. 7 plus 2 is 9. So it means we need to balance the carbon and hydrogen also. So if I'll place 2 before C4H10, so the total number of carbon atom becomes, here we have C12 and H24. So if I place 2 before C4H10, what will happen? 2 multiplied by 4 is 8. 8 plus 3, 11. No, we can't use 2 because this is increasing the carbon atoms. So 2 is the wrong option for butane. Let's place 2 before propene. So we have 2, 3 is 6. 6 plus 4, 10. 10 plus 2 is 12. Again, this is also wrong. What if I place 2 before ethene? Now let's count the carbon atom first. 4 plus 3, 7. 7 plus 4, 11. It's balanced. What about hydrogen? 10 plus 6, 16. 2 4s are 8. 16 plus 8, 24. Yes, it's balanced. So this will be the final balanced reaction equation here. D. Propane reacts with chlorine to form chloropropane and one other product X. C3H8 plus Cl2 gives C3H7Cl plus X. Number 1, name product X. Now this is substitution reaction which takes place in the presence of ultraviolet light. So the other product must be obtained is hydrogen chloride. Because in this reaction, chlorine will replace, one of the chlorine atom will replace one of the hydrogen atom. And the product obtained is substituted alkane and hydrogen chloride. Number 2 is state the essential conditions for this reaction. The essential condition for this reaction is ultraviolet light. So I will write ultraviolet light. You can even write diffused sunlight. Move to next part. E. Ethene reacts with bromine at room temperature. Figure 4.2 shows the displayed formula of the reactants and products. So here's the reaction. Number 1, calculate the enthalpy change of this reaction in kilojoule per mole. Use the bond energies in table 4.1. So bond energy is provided. We need to calculate the enthalpy change. You know the formula? Energy needed to break bonds minus energy released when bonds are made. So first of all, we'll see which of these bonds are broken. You see, C double bond C, it's broken. So we have C double bond C here, one C double bond C. And we also have Br bond Br. It's also broken. That's why we are getting the product here, which is dibromoethane. The product is dibromoethane. What about the product side? On the product side, we are having bond form, which is CBr. CBr, there are two CBr bonds. And we are also having C bond C. C bond C is also there. So what I'm going to do, there's one C double bond C, so I write 612 plus 1 Br 193 bracket minus energy release when bonds are made. We have CC bond, which is 347 plus 2 bonds of CBr. So you have to multiply 290 by 2. So the final answer, 612 plus 193, we are getting 805 minus 290 multiplied by 2 plus, we are getting 58 plus 347, 405. Sorry, there's a mistake. I need to do this again. 290 multiplied by 2, we are getting 580. 580 plus 347, 927. So 805 minus 927 minus 122. This will be the final answer. Minus 122 kilojoule per mole. Last part of this question. Number 2, describe the color change when a sample of excess ethene is added to a few drops of aqueous bromine. So the color change, what's the color of aqueous bromine? It's brown or orange. Brown or orange. But in solution, when they are saying solution, it must be orange because at room temperature pressure, bromine is brown. So in the solution, it must be orange. So you write orange here. And it will get decolorized. Orange to colorless. Question number 5. A student adds large pieces of copper 2 carbonate to dilute hydrochloric acid. The copper 2 carbonate is in excess. A. Complete the equation by adding state symbols for the products. You have reactant CaCO3 solid plus 2 HCl aqueous gives CuCl2. So recall all chlorides are soluble except lead, mercury, silver. So it should be soluble. So I will use AQ for this. H2O, water exists in the liquid state. So I will use L. CO2 is carbon dioxide. It exists in the gas state. So I will write G here. B. Figure 5.1 shows how the mass of the reaction mixture changes with time as the reaction proceeds. So here's the figure 5.1, and you can see it clearly. The mass of reaction mixture, it decreases. It decreases with time. Number 1, in another experiment, powdered copper 2 carbonate is used instead of large pieces of copper 2 carbonate. All other conditions and the mass of copper 2 carbonate stay the same. Draw a line on the grid in figure 5.1 to show how the mass of the reaction mixture changes with time. Now, initially they are using large pieces of copper to carbonate. Now they are using powder form. And you know that powder form, they have large surface area, and this also increases the rate of reaction. There are small particles present in the powder form. They are more exposed, so they have better chances to react. So you will have steeper gradient initially, and you have to start the line at 0. You have to start from here, this point, and ends at same final mass. So here's the final mass. It will be like that. Which indicate the reaction rate will be faster in this case. Part 2. The initial experiment is repeated using large pieces of copper to carbonate and hydrochloric acid of higher concentration. All other conditions stay the same. Describe and explain the difference in rate of reaction when hydrochloric acid of a higher concentration is used. Definitely rate increases, but you will not get marks for this. It's of 2 marks, so it's obvious that the rate will increase. So you can write either reaction is faster or rate increases. Now for the 2 marks, you have to mention there will be more particles per unit volume. More particles per unit volume. You can even write particles are more crowded, or particles are more crowded. This will give you 1 mark. For the next mark, you have to write more collision. There will be more collisions per second, or the collision frequency will be greater. You can write one of these statements. Part C. Excess copper to carbonate is added to 22.0 centimeter cube of 0.5 mole per dm cube hydrochloric acid. Calculate the volume of carbon dioxide released measured at room temperature and pressure. Give your answer to 2 significant figures. Now we need to calculate the volume of carbon dioxide. So I'm going to show the relationship between hydrochloric acid and carbon dioxide using this equation. We have 2 moles of hydrochloric acid and 1 mole of carbon dioxide. So write 2 moles HCl giving 1 moles of CO2. This information will be needed later on. So first of all, what I'm going to do, I will calculate the moles of hydrochloric acid using this information. Moles of HCl. 0.5 mole per dm cube means 1000 centimeter cube contains 0.5 moles. 1000 centimeter cube contains 0.5 moles. Therefore, 22 centimeter cube contains X moles. Do the cross and equation will be like this. X is equal to 0.5 multiplied by 22 divided by 1000. . 0.011. 0.011 moles. Fine. Now you got the moles of hydrochloric acid. We can calculate the moles of carbon dioxide using this information according to the reaction equation. Two moles hydrochloric acid giving 1 mole of carbon dioxide. Therefore, 0.011 moles give x mole of carbon dioxide. Do the cross, you will get to x equal to 0.011 divided by 2. So 0.011 divided by 2, we will get 0.0055 moles. 0.0055 moles. Now, in order to get the volume, we know that 1 volume of any gas, 1 mole of a gas at RTP means room temperature pressure, occupies a volume of 24 dm³. So we need to multiply the moles by the 24 in order to calculate the volume of carbon dioxide. So 0.0055 multiplied by 24. The answer is 0.132 dm³. D1. Describe the observations made when a few drops of aqueous ammonia are added to an aqueous solution containing copper 2 ions. We know that it produces blue precipitates. So I will write blue precipitates. Excess aqueous ammonia is added to an aqueous solution containing copper 2 ions. So this will dissolve in excess to form dark blue solution. So you'll write dissolves to give dark blue solution. Part 2. An ionic compound of copper has the formula Cu2O. Reduce the oxidation number of copper in Cu2O. Now we have 2 atoms of copper. Cu2O means we have 2 atoms of copper and oxygen. There's 1 atom of oxygen. In order to calculate the oxidation number of copper, we need to know the oxidation number of oxygen. Where is oxygen? Oxygen is here in group 6. It must be having -2 as its oxidation number. So I will write 2x plus bracket -2 is equal to overall is equal to 0 because there is no sign on Cu2O. I mean no charge. So it will become 2x minus 2 is equal to 0 or 2x is equal to plus 2 or x is equal to plus 2 by 2. So the answer must be plus 1. So the oxidation number on copper is plus 1. Into next part. Part E, describe how to prepare crystals of ammonium chloride by reacting aqueous ammonia with dilute hydrochloric acid. Now we want to make ammonium chloride by reacting aqueous ammonia with dilute hydrochloric acid. Ammonia, it's an alkali, and dilute hydrochloric acid is an acid. This is the reaction between dilute acid and weak alkali. So we'll go for titration. You can write any 3 from these. Any 3 from. First I will start with titrate. Titrate. aqueous ammonia with HCl. Repeat without indicator. You need to add indicator in this in order to check, in order to obtain the neutralization or endpoint. Repeat without indicator. Next point, evaporate. Gentle heating. Then you will crystallize through cooling. Last one, cool. Sorry. Last one is dry. So you can write any three of these. Moving to next question, which is question number 6. Figure 6.1 shows the structures of zinc sulfide and disulfur dichloride. Zinc sulfide has a structure similar to diamond. The zinc sulfide is a structure of zinc sulfide similar to diamond. It's a tetrahedral. Diamond also got tetrahedral arrangement. The only difference is that diamond is allotrope of carbon, which means contain only carbon. In this case, you are having zinc and sulfur atoms. A1, explain why zinc sulfide does not conduct electricity. Use the information in figure 6.1. So we know that diamond does not conduct electricity because of the absence of mobile electrons. So definitely zinc sulfide, it also does not have any mobile electrons. So you write no mobile electrons. No mobile electrons. Mobile electrons are very important for the conduction of electricity. Number 2, predict one other physical property of zinc sulfide. Now comparing it with diamond, it must be having high melting point because it's also a giant structure like diamond. High melting point. You can even write hard. Diamond is hard. It is also hard, just like diamond. B, explain why disulfur dichloride has a low melting point. Use the information in figure 6.1. If you look at the structure, disulfur dichloride, it must be covalent, having covalent bonding. These bonds are covalent, so it's having simple structure. It's a simple molecule. So we write simple molecule with weak intermolecular forces. Part C. Complete figure 6.2 to show the dot and cross diagram for the electronic configuration of disulfur dichloride. Show only the outer shell electrons. First of all, I'm going to show the key here for both sulfur and chlorine. For sulfur, I'm using cross, chlorine, I'm using dot. Now, let's look at the position of sulfur and chlorine. The periodic table sulfur is present in group 6, which means it contains 6 valence electrons. Chlorine, here's chlorine, it's present in 7, which means it contains 7 valence electrons. Each sulfur atom needs 2 electrons to complete their valence shells. So, both of these sulfur atoms will share 2 electrons with the other atoms. So, in this case, each of the sulfur atom will be sharing one of their 2 electrons with each other, and one with one or other with chlorine atom. So for the right hand side, 1, 2, 3, 4, 5, 6. There will be 6 valence electron for this sulfur. Next sulfur, 1, 2, 3, 4, 5, 6. What about chlorine? Chlorine must be having 7 valence electrons. So I'm going to show the 7 valence electrons for each chlorine atom. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This will be the final dot and cross diagram for disulfur dichloride. D. Disulfur dichloride reacts with water as shown. H2Cl2 plus 3H2O gives 2HCl plus H2S plus H2SO3. 13.5 gram of disulfur dichloride is reacted with 8 gram of water. Show by calculation that water is in excess. Now, there are two ways. You can either use the mass given or convert this into moles. Convert these masses into moles. Now I'm converting these masses into moles. So I need MR of both the compounds here, H2Cl2 as well as H2O. So MR of H2Cl2, sulfur is here, 32 is its nucleon number or mass number. For chlorine, it's 35.5. So we have 2 multiplied by 32 plus 2 multiplied by 35.5, which will become 64 plus 71 or 135. What about H2O? It's very easy. Oxygen, group 6. 16 is the mass number, hydrogen is 1. So 2 multiplied by 1 plus 16, we'll get 18. So now the moles of H2Cl2, 13.5 divided by 135 will become 0.1 moles. What about H2O? 8 divided by 18 will become 0.444 moles. Now, according to the reaction equation, H2Cl2, H2, we have 1 mole reacting with 3 moles. Therefore, 0.1 mole reacting with X mole. Definitely X becomes 3 multiplied by 0.1 is equal to 0.3 moles. So 0.3 moles is needed. So 0.444 mole is provided from the data. So hence it's proved that water is in excess. Hence proved that water is in excess. Moving to next part, which is E. Sulfur dioxide is an air pollutant. Number 1, state one adverse effect of sulfur dioxide in the air. So it's very common. So non-metal oxides responsible for acid rain. So I will write acid rain. Number 2, describe 2 ways of reducing the emissions of sulfur dioxide in the air. Now you have to look for the look for 2 ways of reducing the emissions of sulfur dioxide. We have to use low sulfur fuels. So you can write Ne2 from use low sulfur fuels, do not use fossil fuels or use renewable energy resources, flue gas desulfurization or reacting SO2 with CaO or CaO3. So I will write use low sulfur fuels or do not use fossil fuels. Use renewable energy resources. Flue gas. Desulfurization. Or reacting SO2 with CaO or CaO3. You can write any two from these. Question number 7, part A. Propanoic acid can be represented by the formula CH3CH2COOH. Number 1, propanoic acid reacts with methanol CH3OH to produce an ester. Name the ester formed and draw its displayed formula. Now for the name, recall alkyl group will be coming from the alcohol. So here we are having methanol. So we'll get methyl from methanol and alkanoate from the carboxylic acid, which is propanoic acid here. So we'll get propanoate. Propanoic acid gives propanoate. So the ester must be methyl propanoate. For the displayed formula, remember, you need to remove OH from the alcohol and H from the ester, carboxylic acid, to release water molecule. So methyl, one will be the methyl group C. We have 3 hydrogen atoms for the methyl group, and it's going to attach with the carboxyl carbon O, C double bond O. Now you have CH2 and CH3. Placing hydrogen atoms, this will be the final displayed formula for methyl propanoate. Number 2, propanoic acid is a weak acid. This is a reaction equation CH3CH2COOH plus H2O. Reversible sign CH3CH2COO minus plus H3O positive. Explain how this equation shows that CH3CH2COOH is an acid by referring to proton transfer. Now this hydrogen is removed from this and it's considered as proton because it will be the one having no electron. That's why we call it proton. And it's going to react with water, H2O, and producing H3O positive ion. So what I'm going to write, I will write proton transferred from acid to water. Proton transferred from acid to water. CH3CH2COOH is a weak acid. So how this equation shows, it's not fully dissociated. The acid is not fully dissociated. Or you can even write or ionized. or the reaction does not go to completion. The reversible sign indicates that this reaction is not complete, or the reaction does not go to completion. Number 3, propanoic acid reacts with magnesium. Name the two products of this reaction. Now, it's a reaction between magnesium and propanoic acid. Propanoic acid is a carboxylic acid. It behaves like a typical acid when reacted with metals, metal oxides, metal hydroxides, metal carbonate. So it will definitely produce hydrogen gas as one of the product in this reaction, because when metals are reacted with acid, they will produce hydrogen gas. So you write hydrogen gas. So one product is hydrogen gas. What the other product? Magnesium will be reacting with the propanoate ion coming from this. So you'll write magnesium propanoate. Magnesium propanoate. So the other product must be magnesium propanoate. Moving to next part, which is part 4. Magnesium is a solid at room temperature. Describe the motion and separation of the particles in a solid. The solid state, we know that the motion must be vibrating about fixed position. So you write vibrate about fixed position. What about separation? They are close together. Or you can even write touching. B. Figure 7.1 shows the simplified structures of two molecules that combine to form a polyamide. The top one must be dicarboxylic acid, having carboxylic acid at both the ends. So dicarboxylic acid. And the other structure below is diamine because having amine groups. Diamine. Number 1, complete the diagram in figure 7.2 to show the structure of two repeat units of this polyamide. Show all of the atoms and all of the bonds in the linkages. So the blank box, it must be having NH on both ends. Remember, the combination involves, in this case, must be condensation. In the condensation, there will be release of a simple molecule like water. In this case, OH will be released from each end of this dicarboxylic acid and H from each this diamide. So the product is simple. What I'm going to do, just show NH. No need to write NH2. One H is already removed. This end also NH. And it will be attached to C double bond O. The same way, the other end, C double bond O is attached to NH of this blank box. Blank box represents carbon chain. Now, it's also again attached with carbon double bond O. Other end, carbon double bond O. This will be the final polymer obtained in this case. Number 2, polyamides are polymers. State the meaning of the term polymer. Now they are asking the meaning of the term polymer. It's a large molecules produced from many smaller molecules. Large molecules produced from many smaller molecules or monomers. Number 3, polymers are condensation. Polymers state one difference between condensation polymerization and addition polymerization. So you have to write difference between condensation and addition polymerization. So you can write any one of these, any one from refer to product produce, like in case of addition, only one product obtained. In case of condensation, polymer produced along with the release of a simple molecule. If you want, you can even mention the name of this simple molecule. It can be either water or hydrogen chloride. You only have these two. Or you can refer to the empirical formula. Refer to empirical formula. In case of addition, polymer have same empirical formula. Like polymer and monomer. You can write polymer and monomer. They have same molecular formula, condensation, polymer and monomers have different empirical formula. You can even write addition uses carbon-carbon double bonds. Condensation have or contain monomers with two different functional groups. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.